The objective of this video is to define a rational function and find its domain. Recall that a rational number is a ratio or quotient of two integers, p divided by q, such that q does not equal 0. Examples of rational numbers are 1/2, -2 3/5, 17/25, 0.25, 1.333, where the 3 repeats. So rational numbers can be mixed numbers. They can be decimals that terminate or decimals that repeat. A rational function, r of x, is defined as a ratio or quotient of two polynomials. And we'll say two polynomial functions. That is, r of x is equal to p of x divided by q of x, where p of x and q of x are polynomial functions with the restriction that q of x cannot be 0. Recall that division by 0 is undefined. The domain of a rational function is a set of all real numbers excluding the values that make q of x equal to 0. And recall, these values are called the zeros of that function q of x. Some rational functions are f of x equals 1 divided by x, g of x equals 3x divided by x minus 2, h of x equals x squared plus 2x plus 5 divided by x squared minus x. The domain of f of x is all real numbers except for the values where the denominator is 0. The denominator is 0 at the value 0, so the domain is all real numbers excluding 0. We write that as negative infinity to 0 with a parentheses, union, parentheses, 0 to infinity. The domain of g of x is all real numbers except where x minus 2 is equal to 0, and that occurs at x equals 2. To exclude 2 from the domain, we write that as negative infinity to 2, union 2 to infinity. If it helps, you can draw a number line, put the number that the denominator cannot be equal to on the number line, and think about an open circle at that point. So you can include everything before that number, everything to the left of 2, and everything to the right of 2. And that will help you see how you need to write the interval notation. The domain of h of x is all real numbers except where x squared minus x is equal to 0. That's a quadratic equation we can solve by factoring. We take out an x, that leaves x minus 1 equals 0. So the restrictions are that x is equal to 0 and x is equal to 1. And so if we think about where those numbers are on a number line, the 0 and 1, and we exclude those numbers, then we have to include everything to the left of 0, which is negative infinity to 0, with a parentheses, union everything between 0 and 1, so that would be the interval from 0 to 1, with parentheses on both endpoints, union everything to the right of 1, which is parentheses 1 to infinity. Example 1 is to determine the domain of each rational function. Part A is f of x equals x cubed minus 2x squared plus 3x plus 3 divided by x squared minus 4. The domain is all reals except for the zeros of the denominator. To find the zeros of the denominator, we set x squared minus 4 equal to 0. That is the same as x squared equals 4. Right? We can use the square root property to solve this equation. Therefore, x is equal to plus or minus 2. So to indicate that we exclude the negative 2 and 2, our domain would be negative infinity to negative 2 with a parentheses, union negative 2 comma 2 parentheses, union 2 to infinity. So every number on the number line except for negative 2 and 2. Part B is f of x equals x cubed minus 8 divided by x squared plus 9. The domain again is all real numbers except for the zeros of the denominator. If we set x squared plus 9 equal to 0, we can use the square root property again to get x squared equals negative 9. Therefore, x equals plus or minus the square root of negative 9. But recall that the square root of negative 9 is an imaginary number, so the solutions are plus or minus 3i. Because the only zeros occur at imaginary numbers, that tells us that there are no restrictions from the set of real numbers, and so the domain is negative infinity to infinity, or all real numbers for that problem.